Hello students, and welcome to another how-to video. Today we're going to be calculating the theoretical yield. Our problem is basically going to be us burning seashells, okay, calcium carbonate, and we're going to create solid calcium oxide and carbon dioxide, okay? And our theoretical yield of CaO of 63.5 grams of calcium carbonate. So let's break this down into an equation that we can recognize and understand. Okay, so what we're doing is we're taking solid calcium carbonate, which is CaCO3. Okay, and it's solid. And it's being heated, which is found in seashells, is decomposed by heating into a solid calcium oxide. So we're adding heat, or we can add a triangle there, we can add either. All right, a delta sign. And we're going to form calcium oxide, which is going to be a solid, plus carbon dioxide, CO2. And it's going to be a gas. So if we look here, we have one calcium, one carbon, 3 oxygens, and 1, 2, 3 oxygens. This is balanced. All right, we don't have to do any more work for this equation. It's already given to us. What we have given to us as far as stoichiometry like terms, we have 63 grams of calcium carbonate. So 63.5 grams of this product, of this reactant, which is decomposing. And we're going to find what is the theoretical yield of calcium oxide. How much are we going to make when we decompose this? And this is for a perfect system. So we're going to calculate the theoretical yield. If we were to perfectly collect all the calcium oxide and all the carbon dioxide, how much would we form from this situation? So the first thing you got to do, this is basically a mass-to-mass calculation, and the first thing we need to do is convert our 63.5 grams into moles. So we have 63.5 grams of CaCO3. All right, we're going to do our picket fence, and we need to convert this into moles. So we're going to have 1 mole of CaCO3. Now we need to find that molar mass, which is found in the periodic table. So pull out my periodic table. So we have calcium, which is 40.08. And we're going to add that to 1 carbon, which is 12.01. And we're going to add that to 3 oxygen, so 3 times 16. All right. And that's going to come out to be 100.09 grams. So let's put this down. 100.09 grams of calcium carbonate. All right. All right, let's extend this out a bit. Okay, and our grams of calcium carbonate cancel, and now we're left with 1 mole of calcium carbonate. Now, we're going to use the mole ratio of calcium carbonate to calcium oxide, because that's what we're trying to find, is that mole ratio. And if we notice, it's just 1 to 1. So I'll just write it out. Normally, you can kind of just skip this step because it's basically 1. But we'll do it in this example. So we could do 1 mole of CaCO3 is equal, 1 mole of of calcium carbonate is equal to 1 mole of calcium oxide. Okay. And we're set up our next picket fence. We're going to cross these out. All right, now we have 1 mole of calcium oxide, but now we want to combine it in grams, because our answer was originally given in grams, so we're going to do a mass to mass. We're going to get the mass of the reactants, and we're going to find the mass of this product here. And to do that, we need to calculate the molar mass. So 1 mole of calcium oxide. So calcium is 40.08. We just did this, so I remembered what the molar mass of calcium is. And then oxygen is 16, which is equal to 56.08 grams. And these cancel, and that gives us the units we're looking for. So now all we do is got to go through and do the math. So we got to times 63.5, 1 times 56.08, and then basically divide by 100. So let's do this together. So we have 63.5 times 56.08. Okay, you see that there? And then I'm going to divide by 100.09. And that's going to be equal to 35.58 grams. We'll just go to the hundredths place. 35.58 grams of CaO. Okay, if we were in a perfect system and we did this equation, we could make the maximum of 35.58 grams of calcium oxide. And this number makes sense because it's less than this, because if we're decomposing, we're making two products, and this is only one side of the products, and it has to be obviously less than this amount because the other mass is going to have to go into carbon dioxide. So this makes sense to me, okay? And it's about the same weight, so I mean, it's making sense to me about what this would be, okay? All right, thanks for watching.